As you saw in that last video, what we were able to do is use division to simplify a radical. So in the last round, what we were typically doing is we already had a fraction with a couple of radicals in it. We put it together and then we're able to simplify. What happens in this one is we basically reverse that process. This is a two-way street. So you'll notice in all these I already have one large radical. So it turns out that we can use this in reverse, break it up into two pieces, and then simplify as we go. So when I have the square root of 49 over 64, I can treat this as the square root of 49 divided by the square root of 64. So I just used my division rule. And a little easier to see now because we know that the principal square root of 49 is 7 and the principal square root of 64 is 8. And so we're looking at 7/8 here. So again, breaking it up and simplifying. Same thing here. We can begin by breaking that up. We're looking at the cubed root of 27 upstairs and the cubed root of 125 x cubed downstairs. We know that the cubed root of 27 is 3. The cubed root of 125 is 5. My power matches the index, so we're left with an x there. So again, we're breaking it up and then simplifying. And in these two cases, the radical went away, which is very nice. All right, so again, we start with one big radical. I can break this up into pieces. Consider this the fourth root of 81 x to the 20th and the fourth root of y to the 8th. Fourth root of 81 we know to be 3, right? And then if I use the shortcut, 4 goes into 25 times. So I'm going to have x to the 5th. Down below, 4 goes into 8 twice, so we end up with y squared. Or if you don't like the trick again, we can break this up. So 81 is 3 to the 4th. X to the 20th is x to the 4th, x to the 4th, x to the 4th, x to the 4th, x to the 4th. And we're taking the fourth root. So there's a power that matches the index. There's my 3. There's another power, another power, another power, another power. They all match the index. So how many x's come out? 5. Same thing down below, right? So we're talking about the fourth root. Y to the 8th is y to the 4th, y to the 4th. So power matches the index, power matches the index, we have y squared. So again, that might be the way you prefer, but hopefully you're starting to see that shortcut. We're just using the fractional definition, right? Power divided by indice to reduce as we go. All right, so a lot going on there, but again, initially we're using our division rule to break it up in pieces. We use other rules from the previous sections to continue to simplify our radical, and we're done. So again, another situation where we were able to get rid of the radical altogether. Letter D here, again, we're all underneath one radical, so I'll begin by breaking that up into pieces. All right, and so we're looking at square root of x to the 7th and the square root of 16 y to the 3rd. And again, if we use shortcuts, upstairs here, 2 goes into 7 3 times. All right, we're looking at x to the 7/2, which is x to the 3.5. So upstairs, what we should get is x to the 3rd, and then a square root of x stays in. Of course, if you don't like that shortcut, you can think of x to the 7th as x squared, x squared, x squared times x. And then you're basically matching indices, right, or powers, right? So power matches the index, power matches the index, power matches the index. X to the 3rd with the x remaining in the radical. Down below, the square root of 16 we know is 4. And then if I use the shortcut, y to the 3/2 is y to the 1/2. So there's a y and a square root of y remaining in there. All right? Or you can just think of 16 as 4 squared and y cubed as y squared times y. So there's a power that matches the index, giving me a 4. There's a power that matches the index, giving me a y. And of course, we have a y remaining. Okay, so I'm going to stop right here because it turns out that another rule of simplification is we usually don't like radicals down in the denominator. And so we have to learn how to rationalize the denominator. So that's coming next. So I'm going to put a little asterisk on this guy right here. For what we're learning and what we're doing previously, that would be a good answer. But we're going to build more on this in this section and learn that there's actually more we can do here. So pretty long problem, pretty crazy one. All right, so hopefully you guys are getting used to the simplification idea within conjunction with the division concept. All right, so onwards and upwards, let's go learn how to rationalize denominators.